everyone. So today you guys are all so lucky to hear this awesome lesson on isosceles and equilateral triangles. Alrighty, so we already know a lot about isosceles and equilateral triangles, but now we're going to get down to the nitty-gritty here. So here we're going to talk about and break down an isosceles triangle. So the legs, and I know a lot of you had a question about this on the quiz. The legs are the two segments that are congruent. Okay, so they're the two segments. So we have here, these are the two legs. So we have, let's see, we have AB, segment AB is congruent to segment AC, right? And so those are the two congruent segments of an isosceles triangle, the two legs. Okay, then we have the base. The base is the leftover. Okay, so here the leftover is the base. So we have here, let's see, we have BC. So BC, segment BC is the base, right? And it is not congruent to anything. Okay, I know it's something that we can see. We just have to just know that it's not congruent. If it was congruent, that would make it equilateral, but in this case it is not. It is isosceles. Okay, then we have that vertex angle. So the vertex angle here is going to be A. The reason A is the vertex angle, it is the included angle, okay, it is in the included angle of the legs. So it's the included angle of the legs, right? And remember, the legs are the congruent segments. Okay, then we have the base angles. The base angles, let me get a different color here. So the base angles are the two angles down at the bottom. So we know we have a vertex angle, right? We have a vertex angle, and then the other two angles are called the base angles. So those two angles are going to be congruent to each other. They are formed by the base and the leg. So angle C is congruent to angle B, and again, they are formed by the legs, if I can spell the legs and base. Okay, all right, moving on, let's look at this example here. Without drawing the triangle, name the legs and base of the isosceles triangle. So we want to name the legs, the base of the isosceles triangle. So we have this triangle here, okay? Given that angle R is the vertex. So angle R is the vertex angle. Let me get a lighter color here. So angle R is the vertex angle. Since R is the vertex angle, we know that we are going to have two legs including R. Since R is the vertex angle, we are going to have the legs RS and RT. The base will not include the vertex, so the base will be ST. So the base does not include the vertex. All right, let's go ahead and do a little bit more here. So we have the isosceles triangle theorem, and this is something that you will be using in proofs. Okay, don't think those haven't gone away yet. Chapter 6 is when they're done, so at least for now. But anyway, so here it says if two sides of a triangle are congruent, so if the two sides are congruent, then the opposite angles, the angles opposite of those sides are congruent. So the angles opposite of the sides are congruent. Okay, this is the notation for it that you can write, or you can just say it's isosceles triangle, so you know the opposite angles or opposite sides are congruent. And here is the proof to get that. So we are given that AC is congruent to AB, right? So what I have in orange right now, so AC and AB, that's given. Then we know that AB is congruent to AC. So that is just honestly taking AB, writing that first, and taking AC, writing it second. We know angle A is congruent to itself, right? So angle A is congruent to itself. And then if we were to go about and do the triangles as A, B, C, So that's this first one. And then think of it writing at the back side or going counterclockwise, A, C, B. So technically we have two triangles, quote unquote. And then from here you get that side angle side. You don't necessarily need to know how it comes about, but just know that we are able to say when you have the sides congruent, then you know the angles are congruent. Okay, next we have here it's just the opposite, right? So here's when you get the angles congruent, so you get the angles, so then you get the sides, okay? So that one. That is what that is saying. The next here is equilateral triangles imply equal angular, right? Angular is angles congruent. Here, these are the segments are congruent. And then here in an equilateral triangle, that implies that all of the angles are 60 degrees. So when you have a triangle, when it's equilateral, all of them will be 60 degrees. 60 plus 60 plus 60 is 180. All right, let's go ahead and do a few examples. So then we have find x and y for each of the diagrams. So in this here, we have a lovely isosceles triangle. Because those sides are congruent, we know those angles are congruent. So here, if those two are congruent, then we know angle x is 72 degrees. If that is 72, we can absolutely find this angle here for y, because we know if we do x plus y plus 72, that will equal 180. We know that our x is actually 72, right? So 72, when we subtract those, we'll get y equals 36 degrees. Alrighty. The next one here, those bottom angles are congruent. Awesome. So if those are congruent, we can do 180 minus 40, right? And then divide it by 2. Because if we divide it by 2, right, if we do this, it'll get 140, right? And then we divide that by 2. We'll get both of what those angles are. So this angle is 70 degrees, and this one is 70 degrees as well. So y is 70 degrees. And then we can find out what x is, because we know if those base angles are congruent, that means the opposite sides are congruent. So here we have 3x plus 12 equals 5x minus 16. And then we will get here x equals 14. So we'll get 14 here for x. All right, next, this is a heavy duty problem. So my suggestion is right now, I would like you to pause this video and try this yourself and see what you get, okay? If you are still a little confused and you'd like to hear me walk through it, go ahead, absolutely. But at this point, if you would like to pause and then see if your answers line up, go for it. Try to see what you know. All right, so I'm going to go ahead and continue with this problem. So here, this is a linear pair, and right, we're only given the 125. That's all we are given. So there's a couple of things that we can do. But the first thing I'm going to do is I'm going to find out what 1 is. So to find angle 1, we're going to do 180 minus 125. That's going to get us 55. So that means angle 1 is 55 degrees. Okay, we know that we have these parallel lines here. I'm not parallel lines. We have the two lines, those two segments are congruent, which makes that middle triangle an isosceles triangle. So angle 5 is also equal to 55 degrees. Okay, so the next thing that we could do a couple of things here. So what I actually would like to do is, I know that if this here is 55, this is 125, just kind of adding some things I know. Angle 6 is going to be 55 as well, so 55. Okay, so I'm going to put 55 degrees. Now, a couple things that we can do, let's see here. We know that these two lines are parallel. And if I go ahead and highlight this line here and kind of disregard everything else, I know that this angle here and this angle are alternate interior angles. Okay, so they're alternate interior angles. So then I can go ahead and then say that angle 3 is 55 degrees. Angle 3 is 55 degrees because they're alternate interior angles to angle 5. And then from there, we can also do the same exact thing for angle 2, right? Because if I were to highlight these again and look at this line as the transversal, this line, this angle here, and this angle are also those alternate interior. So angle 2 will also be 55. degrees. Alrighty, so angle 2 is 55 degrees. The next thing is, that might be helpful, right? Because we need to find angle 4. But I know that if I knew what this angle was here, I could get angle 4 because those are vertical. So I'm going to go ahead and I'm actually going to do 180 minus 55 to get what this angle equals here. Okay, and when we go ahead and do that, we get 70 degrees. That means this is also 70 degrees because it is vertical. All right, that is all I have for these notes. Your homework here is the 4.6 homework. Okay, so the 4.6 homework, it is the worksheet. It's a couple problems similar to what you saw today. Number 4, I suggest you start where you are given, right? So we're given this here. So you're going to start with angle 2 and then go to angle 1. So start with angle 2 and then go to angle 1. I promise that'll be more helpful, okay? And then don't forget to write down all of your notation that you are given to help you. Okay, as you see, there's no proofs on this homework, not too long. And then we'll go ahead, and this is the last lesson for the entire unit. If you have any questions, let me know. Okay, bye.